Hello everyone. My project is gender classification from text. So this presentation is for stakeholders. So let's get started. So use case is given a set of label blocks written by males and females. Then predicting the gender of the author of a new blog is our use case, and it basically helps to figure out what kind of products male or female buy the most, or what kind of topics most discussed by male or female. So this classification gives companies a better strategy for advertising for specifically targeted gender and improve product development. So the data set, you can find the data set here. This is a sample data set where we have two columns. One is blog, one is a class which is written by man or female. So here you can see the in the first column we have paragraphs, and then the second column is the target class, whether it is written by male or female. So the is the model. So I just implemented 1 gram and 2 gram features. There are total 5,60,000 features, and then I just took top 1 lakh features and then applied to feature selection from the model, where I applied stochastic gradient descent on SVM, and then selected features, reduced features, uh, and then applied stochastic gradient descent on SVM again. So here you can see the classification report. Basically, you can see precision, recall, and the F1 score, and the support accuracy is around 83%. This is a class prediction error where a number of male or females, where number of males are classified as females, and then a number of females who are classified as male. You can see the error. So this is for thank you for the stakeholder presentation, and now let me present you the second presentation, that is for data science peers. So the use case is basically the same written BC or the previously. So this is same data set, and the pre-processing just remove all the stop words and remove all special characters except the following. These are the special characters most used by male or female. You can see the list of special characters that are frequently used by male or female, and then I remove patterns like the numbers and then a few metrics kind of numbers. So you can see the 10 a.m., p.m.s, and kg, so like that. So my classifier is stochastic gradient descent on SVM. So in order to apply the stochastic gradient descent, the cost function should be convex function. So here is the cost function of the SVM, and then we just verified if it is convex or not. So the first term is a sum of max of the linear. So linear is convex and sum max preserves the convexity. And the second term, square norm is convex. So and the non-negative scaling preserves convexity. So the objective function is to minimize the convex function. Here's the model you previously seen. So we just took features, top features, and then applied stochastic gradient descent and selected features, and then again applied stochastic gradient descent. So here you can see the classification report. Now you previously saw it, and this is a precision recall curve where you can see the precision and recall on the y and x-axis respectively, and the average precision is around 89. So you can see the area under the ROC curve. So it's the AUC is around 91, 0.91. So it's true positive right to false positive right. You can check the confusion matrix where the true positives and true negatives are 420 and 386, and the rest are false positives, false negatives. So this is the class prediction error. You previously saw it where number of predictor classes and the actual class. So I just performed grid search cross validation to tune the hyperparameters, where I split the train and tested is 70 and 30. I just performed 5-fold cross validation, and the best parameters turned out to be alpha is 0.0001 and regularized the result to norm. So this is a t-SNE visualization of the whole document. Whole documents that are around 3,232 that are classified as male or female. So 1 is a male and 0 is a female. I just forgot to mention that. So thank you for now. We'll look at the Jupyter notebook implementation of the project. Okay, you can see that here. We are just importing the necessary SQL and pandas packages, and these are the visualization packages. I just use Vellobricks for visualization. Here we are reading the data and just performing the simple processing techniques here. I just dropping the um, yeah, null values, and here I'm just converting it to string, the block type to string, and then mapping the male to 1 and female to 0, and then perform pre-processing techniques where I replace these special characters with these strings, and then apply some regular expressions to um, replace some characters, substitute. And then I just use the TF-IDF vectorizer to generate the features, and where I took maximum features to 1 lakh, and then gram range is 1 to 2, and stop words are from English, so it all it all ignores the stop words that are in English. So you can see the initial vector size is about 1 lakh features for 3226 documents. So here where I apply the feature selection from the model, where I applied stochastic gradient descent, and then I took the select, and I select features from the model, and then again I apply the feature selection, where you can see the intermediate vector size and the final vector size, where 1 lakh features are reduced to 23,000, and then final vector size is 8,000. Final features are around 8,167. Here we can see the train test split. It is a 7:3 ratio. As stratified on the class, target class, and this is a git search class validation where hyperparameter tuning is happening. So here are the hyperparameters for our model. You can see here penalty, L2, and elastic. And training and evaluating, training and predicting the target class. Here we can see the classification report, the accuracy, number of train and test features, and this is the best score, the best parameters from the grid search class validation. This is the classification report. You can see precision recall F1 scores and the confusion matrix, as we've discussed previously. This is the area under the curve that is visualized by yellow bricks, and this is the precision recall, and this is the class prediction error, and this one is the leading curve. And here you can see the t-string visualization of total documents. You can see that, and this is the implementation using the deep learning. I just applied the sequential model of 6 hidden layers with 100 each nodes. Here we can see that the accuracy to be pretty good than the model implemented by sklearn. So here you can see the accuracy to be 91%. So that's it, guys. Thank you for watching. Thank you.